Hi! Welcome to Chapter 3, Section 3.1. You need to open your book to page 97. At the top of page 97 is a red box. Has the addition property of equations and the subtraction property for equations in it. I need you to copy the red box into your notes. So go ahead and pause the video so that you can do that. Now that you have done that, we can talk about what was in the red box. The addition property of equations means that whatever you add to one side of the equation, you have to add to the other. Likewise, the subtraction property says whatever you subtract from one side of the equation, you have to subtract from the other side. Because whatever you do to one side of an equation, you always need to make sure you do that to the other side. So first we're going to look at the addition property. The whole idea is to get the letter on one side by itself. And I know it's not like you haven't done this before. I know you have, but just stick with me for a second. So for the addition property, remember whenever you have an equation that you're told to quote-unquote solve, when they use that word solve, that means your answer needs to look like some letter equal to some number. So that means you got to get the letter on one side by itself. In order to do that, the first thing I'm going to do is draw a line so I can denote which side is which. That way I have the left side conveniently located on the left and the right side conveniently located on the right. So I can talk about left and rights. Now, I need to get the A by itself. So if I'm going to do that, I have to do something to this side so that only my A is left. So right now I'm subtracting 7, so I'm going to do the opposite, which is adding 7. If I do it to this side, the rule says that I have to do it to the other side. Whatever you do to one side, you have to do to the other. So now that I've done that on this side, my negative 7 cancels out with my positive 7, and the only thing I have left over here is an A, which is good, because that's what I wanted by itself. And then that has to equal whatever is left on this side. So 24 plus 7 is 31. I know I'm done because I have a letter equal to a number, which is what we had to get for the word solve. Now, all that seems real easy, fine and good, and you've done it before, and there's no big shocker. But I want to caution you about some things. Let's take a couple of more. As you can tell, I stuck with the 7 and 24 theme. So we have A plus 7 equals 24. Before, our problem was A minus 7. This time it's A plus. So just like I said, I'm going to draw my line. What do I have to do in order to get the A by itself? That means I'm going to have to get rid of my 7. So I've got to do the opposite in order to get rid of stuff. Since this is plus 7, I need to subtract 7. So I have to subtract it from the other side. That's going to make that 7 go away and that one go away because a positive and negative 7 cancel each other out. That gives me A on this side equals 24 minus 7 is what? Not 31. So A is 17. For this one, I want to get the A by itself. So the thing that's keeping the A from being by itself is the 7. How do I get rid of the 7? I have to do the opposite. Since this is a positive 7, I have to still subtract 7. Whatever I do to this side of the equation, I have to do to that side. So I'm going to subtract 7 from that side too. These cancel each other out, and I'm left with A equals 24 minus 7, we just said, was 17. No big shock. We did the exact same thing. The only difference is the A was in front here and the 7 is in front there. We got the exact same answer. When I do it here, the question is, am I going to add 7 or am I going to subtract 7? So a lot of students would look at this and say, since there's a subtraction sign there, we need to add 7. But that subtraction sign there isn't on the 7. Remember we talked about how the signs in front are the signs that go with the number? So the sign in front of my 7 is a positive. It's just not written down. So when I do the opposite to get rid of it, I have to do the opposite of that positive. So I'm going to have to subtract 7. Make it the opposite of that number, not whatever this operation is. Because that operation goes to that letter, not to this number. It's whatever's in front of it that goes with it. Since I subtract 7 from that side, I have to subtract 7 from that one. My 7's cancel out, and I'm left with negative A this time, equals 17. But that is not done yet, because we don't have a number equal to a letter, or a letter equal to a number. We have a negative letter equal to a number. So I need to get that negative sign gone. Now I know you know how to do it, but I'm going to teach you a faster way, I hope. So you can trust that if this is true, that the opposite of everything is going to be true too. So I can take the opposite of A, which we talked about, or the opposite of negative A, which we talked about was positive A, and the opposite of 17, which is negative 17. So if one of these is true, then the other one has to be true. Taking the opposite of everything. It's faster than sitting there and dividing everything by -1, which is what we'll do in the future, believe it or not. But that's a faster and easier way to understand. Okay, so you see that you got to be really careful about where the minuses are, and that signs really do matter in front of the number. You have to understand whether your number that you're getting rid of is positive or negative, so you know what to put below it, because you always have to do the opposite to get rid of stuff. Okay, let's look at a couple more. I know you don't want to do this step because you don't understand the value in it yet, but you're going to understand, and I don't want your understanding to have to be during a test. So if you go ahead and do the step of drawing the line, then nobody has to fuss at you for not drawing the line whenever it changes your answer. Sometimes it will. So, first thing I'm going to do is draw my line. Now over here, I can rewrite that. I'm suggesting that you rewrite it. So we know that the opposite of a negative is the same thing as plus a positive. So that really says m plus 2 is equal to 12. Go ahead and get rid of your parentheses before you ever do any adding or subtracting. So now I want the m to be by itself. So I'm going to have to get rid of my positive 2. I have to do the opposite to get rid of it. So I'm going to have to subtract 2 from both sides. That makes those 2's cancel out. I'm left with m on this side equals 12 minus 2 is 10. Over here is the same thing, only we use decimals. Don't panic. You have a calculator. I don't have a calculator here, but you have a calculator there, so you're fine. So, I draw my line. I want to get the x by itself, which means I'm going to have to get rid of the negative 3.4, because that's what's keeping that from being by itself. So if I have to move my negative 3.4, that means I'm going to have to do the opposite. And the opposite of negative 3.4 is a positive 3.4. So I need to add 3.4 to both sides. That makes that side cancel out. And I get x is equal to negative 9.5 and a positive 3.4. Different signs mean you subtract and keep the sign of the larger number, so you get a negative 6.1. Hey, look, I'm right. So, a couple of things we learned today. You always do the opposite to get rid of numbers. And you always need to take care of parentheses before you add or subtract. And the big rule, the one that today was really about, whatever you do to one side, you have to do to the other. Today's classwork. Class exercises. Numbers 1 through 14, all. Want to make sure you know what you're doing. And then the homework is going to be the practice exercises. Numbers 1 through 25, odd. And then 43, 45, and 47. And I would say I'll see you tomorrow, but I know you have to do it on the same day. So, I'll see you today. Just a minute. Bye.